طيب بسم الله الرحمن الرحيم. So last time we started to talk about chapter 4 and we have talked about some encoding and signaling techniques. Today inshallah we'll continue this talk. So we'll define some important definitions like what is the difference between bandwidth and throughput and goodput. And then we'll talk about the properties of the different cables and the sources of interference to these cables and how we can mitigate them. So to start, what is the definition of a bandwidth on any physical medium, and what is the difference between this bandwidth and the throughput? Anyone wants to participate? No participation. People are still trying to wake up. Okay, so the bandwidth is actually the theoretical limit of the amount of bits that can be transferred over any physical medium. So it's the theoretical in the sense that the theoretical limit means that it's not achievable in practice, and it's actually one for each physical medium. There is one number that represents the amount of theoretical amount of bits that can be transferred over this physical medium. This bandwidth is calculated mathematically and experimentally in some cases, based on what? Based on the physical properties of the cable of the physical medium and the encoding scheme that we use. And so on. So these, based on these properties and this encoding schemes, we calculate mathematically some theoretical limit of the amount of bits that can be transferred over this physical medium. In practice, this is almost never achieved. So we cannot really achieve this in practice. Why? Because of so many things, because of some environmental phenomena that we will talk about today. The theoretical limit is almost never achieved, and that's why in practice we have the bandwidth, but we also have what we call a throughput. The throughput talks about the actual. So the bandwidth here, bandwidths talk about the theoretical bits per second over the physical medium. The throughput on the other side talk about that the actual bits per second over this physical medium. The actual after taking into consideration all the environmental phenomena and the amount of collision that can happen and so on and so forth. We will talk about many of these as we go through the course. So after taking into consideration all these environmental factors, then what we achieve in practice is sometimes in the range of 40% or 50% of that physical or that theoretical limit, which is what we call the bandwidth. So after taking into consideration all these environmental phenomena, so we calculate what we call the throughput. So for example, to use a specific type of cable, maybe the bandwidth on that cable using certain encoding scheme and so on is around 1 gigabits per second, right? So we can use that cable and we start doing some communication over that cable. Can we achieve this 1 gigabits per second? Of course not. What we can achieve is like 700 megabits per second or 500 megabits per second. That's what we call the throughput, which is the actual bits per second that can be transferred over the medium. And that varies across different times of the day, across different types of cables and stuff like that, because based on different environmental factors, it might vary, it goes up and down. That's what happens to many of us, that we have plans in Ooredoo. Masalan, someone has a plan in Ooredoo like 100 megabits per second. But do you actually ever achieve that in practice? When you download a file, do you actually get 100 megabits per second? Of course not. What you get is actually much less than that, and that's what we call the throughput. So the key word for throughput is actual, the actual bits per second that can be transferred over the physical medium. So after we take into consideration all these environmental factors, we get some bits, some amount of bits at the physical layer. Of course, we get certain bits as a throughput. Of course, these bits, when we structure it, we have the frame header, we have the frame trailer, we have the network header, we have the transport header, and so on. Okay, so what we have in the middle here is the actual data, or the usable data, the amount of usable data that can actually be transferred over this physical medium. So after taking out all these headers, we call this the the amount of usable data that can be transferred over that physical medium. We call this, in that case, the good put. Okay, so after taking out all the protocol overhead, all these headers are protocol overhead. So when we take out all these protocol overhead, we call this the good put, or the amount of usable data that can be transferred over the physical medium. ماشي كده يا شباب؟ So that's the difference between bandwidth, throughput, and good put. So this will get us through this activity. So the bottom half of this activity we didn't talk about last time. So what is the definition of how can we match the bandwidth, good put, throughput, and so on with these definitions? So how much usable data is transferred over a given amount of time? What is this? Anyone can answer, يعني. Anyone can answer. Just say by the voice and answer. Good put, تمام. So this is a good put. Okay. طيب. Amount of data that is allowed by the medium to flow during a given set of time. The allowed, the limits. This is bandwidth. تمام. And this is the actual measure of data bits over a given period of time. So it might actually vary throughout the day. So this is what we call the throughput. A technique to convert voice analog to digital signal. I didn't talk about that, but I can, if I don't know the answer for a question like this, so let me answer the other one. And the remaining box will be this one. Yani just to teach you some tricks on how to know the answer by the process of elimination. So the transmission method where the carrier frequency varies according to the signal sent. We know this. We talked about this last time. What is this? Frequency modulation. صحيح. So this is a pulse code modulation. This is the only remaining answer. Okay. So what is pulse code modulation? We didn't talk about this, and you don't really need to know the details about this. Pulse code modulation is another signaling technique which works as the opposite of AM and FM and stuff like that. So, in fact, pulse code modulation deals with input signal as analog signal. So for our voice. So for our voice is like something like this. So pulse code modulation talks about the fact that we will take certain samples, okay, for the analog signal to convert it first to digital. That's why it's called pulse code modulation. And then we take this is like, for example, 8 volt. So 8 volt, we convert it to digital, so it becomes 1000, something like that. And then we end up with set of bits. So this is a way for us to use pulse code modulation to convert the analog signal to digital signal, to bits first, and then from bits we can use codes, and we can use all the encoding schemes and signaling schemes that we talked about last time. So that's pulse code modulation. It does nothing but to sample any analog signal and convert it into digital. Yeah, and we don't have to know much about pulse code modulation at this point, but this is just for completeness. Yeah. طيب, so that's the difference between bandwidth, throughput, and goodput. Today's lecture is actually about the environmental phenomena that affects the bandwidth of any physical medium and causes some kind of impairments. And this is the main factor why we cannot achieve the theoretical bandwidth in practice. So we talk about the sources of noise that come to any kind of physical medium. So we talk about three environmental phenomena. The first one is what we call the electromagnetic interference or radio frequency interference. So by electromagnetic interference, or maybe I can give some chances for people to participate. So what is electromagnetic interference? What is the definition of electromagnetic interference for a physical medium? So if I have a cable like this, and of course this cable has certain signal, okay? What is the electromagnetic interference or radio frequency interference? Any guess? So as time goes by, the people start to ignore a little bit watching the offline videos, even though they are available for the past few days. يعني مين اللي رفع ايده؟ سيد، اتفضل سيد زبير. لا, crosstalk is different. لا, do not confuse electromagnetic interference with crosstalk. Those are two different things. So electromagnetic interference here talks about external source of interference, external source. So this external source might be like some microwave at home. This microwave at home, as you said, it generates some kind of magnetic field that interferes or it affects the quality of the signal inside the wire. So electromagnetic interference here talks about external source that causes some interference with the signal inside the wire. This could be a microwave, this could be a motor doing some vibrations. Usually this electromagnetic interference is in the range of hundreds of megahertz, or in the range of 2.4 or 2.5 gigahertz at maximum. So this electromagnetic interference affects the signal inside the wire. So that's one source of noise that affects the quality of the signal inside the wire. Number two is what you said, Sayed, or you mentioned in the middle, which is what we call crosstalk. Crosstalk. So what is crosstalk, ba? Crosstalk is different. What is crosstalk? محمد زيهان, تفضل. محمد زيهان, تفضل. So you have another signal like this. So you have two wires close to each other, okay, of the same type. They have the same type of signal. So these two signals, they affect each other. They do some noise, or they do some interference to each other. This is خلينا نكتب بس الاسم. طيب, so just to get the difference between electromagnetic interference and crosstalk. So let's assume that I'm talking to Muhammad now. I'm talking to him and we are close to each other, and I'm talking and he's listening. So the talk is going and we are communicating very efficiently. And all of a sudden there is an alarm. Alarm represents an external source that produces a very high voice. This high voice will interfere with our conversation. So Muhammad will no longer be able to listen to what I'm saying because of this alarm. That's what we mean by electromagnetic interference. It's an external source that interferes with the ongoing communication or the electric signal inside the communication or inside the wire. Crosstalk talks about the fact that I'm talking to Muhammad now, and we have voice signal going on, and then Hassan is talking to Sayyid, okay, and Hassan is talking to Sayyid very close to us, and they are also talking. So in that case, you have two voice communications, and both of them are going on at the same time, very close to each other. So in that case, they will cause what we call a crosstalk, or they will cause interference, and this interference is caused by the same type of signal on the same type of wire. Number three, which is a bit tricky, I don't expect you to know much about it, which is what we call dispersion. So dispersion is a very interesting phenomenon, because dispersion is some natural phenomena that it will happen no matter what you do. Like electromagnetic interference, let's say electromagnetic interference, we can try to avoid any external source, so we will not cause interference. Crosstalk, okay, so we will have one wire only, so we will not have two wires close to each other, so we can, sort of reduce crosstalk. But dispersion, in fact, is a natural phenomena that is caused by the fact that when the signal goes inside the wire is some kind of a physical medium that has some impedance, some resistance. Okay, so this resistance will cause the electrons, because at the end of the day, the signal is just some kind of an energy. Okay, and you have electrons, and these electrons, they dissipate. Okay, so they go in multiple directions like this. They cause the fact that the energy of the signal gets lost and attenuated. So after some time, the signal dies. Okay, so that's actually one of the reasons that we cannot actually make these cables as long as we want. So we have certain limit on the amount of length that we can have these cables, because this dispersion happens no matter what you do. So this dispersion causes the electrons of the signal to dissipate, and it loses the energy due to the resistance of the cable. Okay, طيب, so this is another type of, again, it's not interference, but in that case, it's another source of losing the energy of the signal, and that also causes some impairment to the energy or to the signal inside the physical medium. So having said that, we need now to talk about the different types of cables and how the design of cables took into account each of these sources of interference, and how did we design the cable to mitigate these sources of interference. So the first type of cables is, of course, the copper cables, and we kind of mentioned some types of copper cables before. So we have three types of copper cables, which are the most common ones. So what are these? Three types of cables under the category of copper cables. هاني تفضل. هاني جعفر. Okay, and shielded twisted pair. Okay. Coaxial. Okay, so what is the difference? Any kind of difference between these three, Ahan? Okay. UTP is composed of one wire or multiple or what? يعني you have one wire only for UTP, or you have to have multiples of these wires? Multiples. Okay, so UTP and STP, they both talk about very thin copper, very thin copper. Okay, and this copper, you have 8 of these thin coppers or thin copper lines to represent or to be packaged into one cable. Okay, so 8 of these wires, and that's the case for UTP and STP. Okay, so you have very thin copper. Okay, and you have 8 of them. Okay, so if we put 8 of them, of course now we need to talk about how can we mitigate these sources of interference in the design of these cables. Okay, so first, what UTP and STP do in order to mitigate the dispersion. So the first thing they try to do is to mitigate dispersion. Okay, how do UTP and STP mitigate dispersion? Any guess? ساير اتفضل. لا يعني how do they mitigate dispersion in particular? No, no, no. The outer jacket على فكرة outer jacket is just used for packaging، بس مجرد ان هو بس بيباكج ال 8 wires مع بعض، انما the outer jacket is not really used for mitigating any source of interference. Okay, outer jacket is just for packaging. But inside this outer jacket, we have three types of materials to try to mitigate each of these types of interference that we talked about. Okay, and it's not what someone typed exactly. So for dispersion, the first thing we do is that for dispersion we use plastic insulation. So each of these wires, each of the 8 wires, has plastic insulation. The plastic insulation, what it does is that it actually creates some kind of a layer, okay, over the wire. So every time the electrons try to dissipate, so this isolation tries to keep it inside. Okay, so whenever the electrons they try to dissipate, this kind of isolation keeps the electrons inside. So it tries to keep the electrons as long as possible inside the wire, because there is a complete isolation. So the plastic insulation is used to first mitigate the dispersion. Okay, what about crosstalk? How do we mitigate crosstalk? Any guess? احمد محمد تفضل. By twisting the cables. برافو عليك. تمام. ده انت احمد محمد ايه بقى عشان ما اغلطش تاني؟ احمد محمد اسم ايه اللاست نيم بتاعك؟ احمد عبد الحميد. تمام تمام يا احمد. So what happens here is that each pair of wires is actually kind of twisted like this. Okay, so each pair of wires is twisted. Why do we twist it? Because it turns out when you twist it like this, the effect of crosstalk gets cancelled. They cancel each other. When you twist it like this, the crosstalk is reduced because the signals they cancel each other. So the effect of crosstalk is actually minimized. طيب, so this is the second. So now we got rid of dispersion and we got rid of crosstalk. Okay, so now comes the third one. So how do we mitigate electromagnetic interference? So it turns out to get rid of electromagnetic interference, we use another type of material, which is called a braided copper shielding. Okay, or sorry, braided foil shielding. Sorry. So it's a very thin foil material that gets put, okay, on each pair of wires. This material, it turns out to be the most expensive material, and that's why UTP ignores that, and only STP, or shielded twisted pair, it uses this braided foil shielding, and that's why it's called shielded twisted pair, because it has this braided foil shielding material. UTP does not have this material, and because of this, UTP is much cheaper compared to STP. But of course, UTP, because of this, it has the effect of electromagnetic interference. It's prone to electromagnetic interference, and that causes the quality of the electric signal inside to be deteriorated a little bit. And that's why for UTP, we usually use UTP up to some bandwidth in the range of 1 gigabits per second. Whereas STP, it can get up to 10 gigabits per second. So that's the difference between the two. And why the STP can get to 10 gigabits per second? Because of this braided foil shielding material, which is kind of expensive, but it actually eliminates the effect of electromagnetic interference, and that's why it can get higher bit rate. Coaxial بقى has similar properties, but the first thing we know about coaxial is that it's only one wire. It's only one thick wire. Okay, so it's only one thick wire like this. So all of a sudden we got rid of crosstalk because we only have one wire. Okay, so we don't have two wires next to each other, so we don't have any effect of crosstalk. And we have طبعا after this we got rid of crosstalk, so we have the plastic insulation. So then we have plastic insulation, okay, to mitigate the dispersion, and then we have the braided foil shielding. So this is the braided foil shielding as well. So that's why coaxial is similar to STP, but the problem with coaxial is that because of the fact that we have one very thick wire like this, it makes the handling and bending of that wire a little bit more difficult compared to UTP and STP, because UTP and STP is very, very thin wire and multiple of them. The bending of UTP and STP is very easy, so you can do that, and that's why it's easy to be used in complex lab setup where you have multiple machines and you can bend it around the lab as you wish, and in this way we can use it for data communication easily. The problem with coaxial is that because it's one thick wire, so if you try to bend it like this and move it around, it's not that easy. And that's why coaxial nowadays is not actually used anymore for data communication. Coaxial is limited to the use of connecting antennas to wireless devices. So like TV, like any kind of wireless device, we use coaxial cables to connect antennas with wireless devices. Okay, but it's not used for data communication anymore. So that's the first type of cables. The second type is fiber optics. Okay, so fiber optics has we have two very common types of fiber optics. Can anyone give me those two types and the difference between them? اتفضل يا ساير. ساير اتفضل. Single A. Make your answer يعني clear. Single A. what is this? Which one uses the core? Which one uses this thin and which one uses the not thin? Okay, so the single uses thin core of A. What is the material here? Of glass. Okay, so for single, we use very thin glass material for the core. Okay, so it's called single mode fiber. Okay, and multiple mode fiber type. What is the difference between the two? One is thin and one is, I take it from you that it's a little bit thick, right? So for the multimode fiber is thick, so the glass itself is thick. Type. What is the implication of this? What is the source of what is the source that we use for single mode fiber? The source of what type of material? What type of signal goes into that glass? Optical signal or light. صح. So what is the type of source that we use for single mode fiber versus the multi-mode fiber? What is the name of the source of the light? Yeah. For single mode fiber, we use what? We use what source of light? طيب. So for single mode fiber, we use laser. We use laser as the source. So laser, as we all know, it's a very sophisticated light source. It's more expensive, obviously, and it actually generates one single beam that goes in a straight line. Okay, so it does not يعني deviate from a straight line. So it's line of sight. So it has to go with the thin glass, okay, in a straight line like this. ماشي كده? It's one single beam of light. The multi-mode fiber, it uses light emitted diodes. We all know LEDs. We dealt with LEDs in the lab before. So LEDs are very cheap source of light. But the problem is it does not generate a single beam of light like this. It actually generates multiple beam of light that it goes into not that straight line, but it goes in different directions. Okay, so it goes in different directions and it deviates from the straight line, and that's a big problem for multi-mode fiber. So we have to use some kind of mirrors around the cable to try to reflect. Every time the beam tries to dissipate, it actually reflects. So this mirrors correspond to the plastic insulation for the case of the copper cables, but here we have to use mirrors to reflect the light inside. Type. So because of this, the single mode fiber, because it goes in a straight line, all the energy is actually targeted or directed in a straight line. So because of this, the optical signal can travel in a very long distance, up to 63 miles. And that makes it a very attractive type of cable for submarine communication, where you need to go in a very long distance. So you can connect not بقى countries, you can connect continents, قارات, using one or two of these submarine cables using single mode fiber. But of course, as we can imagine, it's very expensive because of the fact that the manufacturing of this thin glass is sophisticated, and also the use of the laser as a source of light. Okay, so that's the difference between the single mode fiber and multi-mode fiber. For multi-mode fiber, because of this dissipation, it can go up to 1.2 miles only. So it's used within a campus, or in a small geographical area. You can use multi-mode fiber, but single mode fiber is usually used for very long distance communication. Type. The third type is wireless. And for wireless, we're not using electric signals like the case of copper. We're not using optical signal. We're using what we call a microwave signals. For microwave signals, the wireless is very, very diverse. So we have multiple technologies for wireless. So we have FM in the range of 100 megahertz frequency. We have Wi-Fi in the range of 2.4 gigahertz and 5 gigahertz. We have even millimeter wave for 5G, which uses terahertz. So we have diverse set of technologies for wireless that we cannot cover in one lecture, or we cannot cover in even one or two courses. So wireless is very, very diverse. So any question about this quick introduction about electromagnetic interference, crosstalk, dispersion, and the different types of cables. So this quick introduction can get us through the following three activities very quickly. So the first two activities are very straightforward. So the first one is about the copper cable. So we have UTP, STP, and coaxial. So what is the new Ethernet 10 gigabytes standard uses this type of copper media. So what is this? Anyone can answer, yani. Just interact with voice directly, yani. No specific one. So STP, tamam. Because we said that the UTP can reach up to only 1 gigabits per second, cannot get 10 gigabits per second. Attaches antenna to wireless device. That's clear. We said that this is the only usage for coaxial. Counters EMI and RFI by using shielding technique. This is also a STP, because we said that and actually coaxial as well. Coaxial also uses braided foil shielding. So we can also take on coaxial because it uses برضه some kind of shielding. Most common network media. Well, this is this is a philosophical question شوية. يعني it's actually the question wants you to say UTP. The question wants you to say UTP because UTP has been the most predominant cable. Why? Because it's very cheap, okay? And because of the fact that we did not actually need 10 gigabits per second in the past. But in fact, we're transitioning into the era of Internet of Things and all of this. So we are becoming more and more hungry for bandwidth and for very, very high bit rates. So STP started to come into the picture. STP like اللي هو Cat 5 بيسموه Cat 5. So STP started to get into the picture and started to be more and more used, and it's now becoming, it's transitioning to be the more dominant cable. And of course, coaxial is not dominant by any means because it's not used for data communication nowadays. So this type of cable terminates with BNC, N-type, and F-type. We did not talk about this. You will talk about this in the lab, so you will know that the coaxial actually uses this type of connectors, اللي هو BNC and N and F-type. Okay. طيب. Second activity here talks about the fiber optics. Again, this is very easy. It's supposed to be very straightforward, and that's why we'll get to it right away. So, can help data travel approximately 1.2 miles or 2 kilometers. So, what type of cable is this? Multi-mode, because we said that single mode it can get to 63 miles or something. Okay. Uses light emitted diodes. I don't have to continue. خلاص. Use light emitted diode. That's a multi-mode fiber because single mode it uses laser. Okay. Type uses laser in a على طول a single mode. I don't have to continue. طالما uses laser, that's single mode. Used to connect long distance telephony and cable TV applications. That's a single mode because of the long distance. If it's long distance, then it's single mode. It can travel approximately 62.5. I told you 63, but yeah, it's plus or minus. So 62.5, that's also a single mode fiber. Used within a campus network. That's multi-mode, of course, because it's not long distance. ماشي كده? This last activity talks about groups all types of interact using voice. يعني someone writes a very very long message, I will not be able to read all of this. But try to يعني unmute and talk using voice. So this activity groups all the cables together, and we will need that to specify some numbers or write some levels like low, medium, high, okay, to answer these questions. So what is the type of signal used? So we need to mention exactly what is the type of signal. So what is the bandwidth? We need to write some numbers here. What is the length? We also need to write some numbers here. We will need to talk about this. Resistance to interference. So I will not mention numbers here, but I can say low, medium, high, something like that. Prices, again, I will not mention the actual price, but I can say low, medium, high. Setup and handling, also low, medium, high kind of thing. So I will give you 1 or 2 minutes to think about the answer here, and then we can discuss it. طيب يا ناصر, take a shot. So what is the types of signal? So for UTP and STP, both of them, they use electric signal. Electric signal, that's clear. Coaxial, electric signal, تمام. Fiber optics, optical signal or light signal. That's clear. ماشي يا ناصر. تمام. طيب, bandwidth. What is the bandwidth? We need to write some numbers بقى هنا. Yeah, اتفضل. Yes. Okay. So 1 here refers to UTP, and 10 refers to a 10 gigabits per second. So STP. Okay. So coaxial, huh? 15. واضح. واضح ان انت اتفرجت على المحاضره دي السنه اللي فاتت او حاجه. ماشي يا ناصر. تمام. So we didn't talk about the bandwidth for coaxial. Okay, but it's slightly more than STP because of this very thick wire. Okay, the thick wire can actually absorb more signal energy, and that's why it can get higher band. But so someone might say, so if it's 10 or 15 gigabits per second, so why don't we use it? Okay, instead of UTP and STP. Why can't we use it instead of UTP and STP? That's because of the fact that the setup and handling, how to handle coaxial for data communication is somewhat tricky because of the fact that when you bend the wire, you cannot really bend it because of the thick wire. You cannot really bend it a lot. Fiber optics, well, يعني, in terms of bandwidth, is very tricky. I can tell you that the amount of traffic that we as human beings, we can achieve on fiber optics is 150 gigabits or gigabytes or gigabits per second. But actually, the fiber optics, they can achieve a lot more than this, terabits per second. Okay, 100 terabits per second. This is the theoretical, but as human beings, we cannot achieve this unless we have the optical routers and optical switches and this and that, which does not exist as a mature technology until today. People are trying to do this, but it's not mature technology as we have it today. طيب, the length for UTP and STP is 100 meter. So 100 meter is the maximum. طيب, how can we go beyond 100 meter يا ناصر? Does that mean that we can only have a network of length 100 meter? The internet is more than that. So how can we reach beyond 100 meter? So once you connect any network device, you can go for another 100 meter. Pay this, keep this in mind. So if you connect a switch, a router, a hub, even an amplifier, bridge, any kind of network device, once you connect it to a cable, this means that you can go for another 100 meter. Okay, why? Because any network device will regenerate the signal from scratch. Regenerate the signal. Once you regenerate the signal, معناها you have another 100 meters to go. Okay, and that's why the internet we can have definitely to cover a campus or to cover a city or a continent or the entire world, because we can connect these wires repeatedly. Coaxial, again, because of the energy that the cable can use, it can get to 500 meters. Okay, fiber optics, we said that from 1.2 all the way to 63 miles. Okay, or around 120 kilometer, which is a lot. Okay, طيب. Resistance to interference. Well, we have to separate now. So UTP, I would say very low, صح? Because of the fact that there is no braided copper shielding. صح? STP high, of course. It can resist because of the braided copper shielding, right? Coaxial also high. Okay. What about fiber optics? Does radiomagnetic interference have any effect on fiber optics? No, absolutely not. It does not have any effect on fiber optics. So it's completely immune. Okay, or I could say not applicable, because radiomagnetic interference, radio frequency interference does not have any effect on fiber. Why? Because fiber optics, it works in the level of terahertz. Okay, and as we said, radiomagnetic interference, it works in the range of a few megahertz, right? So there's no effect whatsoever. The price, UTP is the lowest, of course. Okay, STP, I would say medium, and coaxial, I would say also medium, and of course, fiber optics is higher. Of course, fiber optics is very high, and that's one of the reasons that we limit the use of fiber optics in specific applications where we need very, very high bandwidth in a specific type of environment. Okay, setup and handling for UTP and STP is very easy. That's why these are the most common cables to be used for data communication, and we can connect machines in labs and so on. Very, very easy, right? Coaxial, well, a little bit hard. Okay, because of this very thick wire, we cannot bend it, we cannot move it around a lab setup, okay, and tables and stuff like that. We cannot like tie the cable, okay, using plastic pieces as we do for the case of UTP and STP. For UTP and STP, is very, very flexible. We can bend it, we can turn it around the tables and stuff like that. Fiber optics, it's very, very hard. Very hard. Okay, because we're talking about glass. So glass, you can, if you bend it a little bit, even by mistake, the glass breaks inside the cable and you don't even know. Okay, so it's very, very tricky to handle fiber optics, and that's why before you handle fiber optics, you have to take some courses. Okay, you have to take very sophisticated courses to try to get familiar with how to deal with fiber optics. Very, very tricky to deal with. ماشي كده يا شباب? Any questions?